All right, today we're looking at the product rule and the quotient rule. What we're looking at today. And we need the product rule. No, we're going to be on 126. We need the product rule when I have two functions that are being multiplied and I want to find the derivative of it. And I need the quotient rule when I have two functions that are being divided and I want to find the derivative. Okay, so I'm going to give you the general form of each, and then we will do examples. So what I have here is I have a function that is made up of two functions multiplied together. So I have h of x, which equals f of x times g of x. So I've got two things being multiplied. So I'm going to show you what the derivative is, what the product rule is, and then I'm going to show you or talk to you about how you need to memorize it. So write that down for me. Here's how you remember it. First times the derivative of the second plus the second times the derivative of the first. That's the product rule. So again, Jasmine. First times the derivative of the second plus the second times the derivative of the first. First times the derivative of the second plus the second times the derivative of the first. So what is it, Gary?
First times the derivative of second plus derivative of second times the derivative of first. That's what you just said. 1, 2, 2, 1. That's what it was.
Times the derivative.
You said the derivative twice on the second part of it. First times the derivative of the second plus the second times the derivative of the first. You said the derivative of the second, derivative of the first.
I know that matters.
Yes, it does matter.
Okay.
Of course it does.
So first times the derivative of the second plus the second times the derivative of the first. That's what you need to memorize. Alright, so here's an example. What tells me I have to use the product rule to find the derivative? I have two functions being multiplied. I've got a function right here. I've got a function right there. I've got those two functions being multiplied together. And the product rule again is first times the derivative of the second plus the second times the derivative of the first. So the first would be the square root of x. The derivative of the second would be cosine x. Then I need plus the second, which is sine x, times the derivative of the first. What do I need to think about when I'm taking the derivative of the square root of x?
What's the exponent of the x?
What is the exponent? 1/2. So
1 over.
So it'd be 1/2 x to the negative 1/2. So my derivative would be square root of x, cosine of x, plus sine of x over 2 squared of x, or 2 times x to the 1/2, however you want to leave it. Now, as I told my third hour, your book loves to simplify. What do you think your book would want to do once we got to here?
Simplify.
That's what I just said. But how would you simplify it? What would you do to simplify that?
Give the radical out of the denominator.
Multiply.
Probably
2
Add. What am I going to have to do to add, Jasmine? I'm going to have to get a common denominator. So your book would get a common denominator and then put these things together. Okay? But we're in calculus. We're not in algebra. So I want that answer right there. Okay? You do not have to simplify on the AP test. Therefore, we're not going to be simplifying the majority of the time in this class. There are some things I want you to do, such as I don't want a negative exponent in my answer. I want you to move that. But other than that, find the derivative and leave it is what I'm looking for. I have f of x equals the square root of x times 3x squared plus 8.
This one?
This is pretty straightforward.
What's the product rule again, Cole?
First times the derivative of the second plus the derivative of the first times the second.
That is correct, but that's not how I want you to memorize it.
Oh, well.
But that is the
Still
wrong
correct.
order.
I want first times the derivative of the second plus the second times the derivative of the first. You always want your derivatives to come second.
Oh, okay.
So first times the derivative of the second plus the second times the derivative of the So first would be the square root of x. Derivative of the second would be 6x. Plus the second, which is 3x squared plus 8, times the derivative of the first. Now, it's probably a good idea to memorize what the derivative of the square root of x is. Does anybody have it memorized yet?
1 half x negative 1 half. Negative 1 half.
It is 1 over 2 square root of x. So it's pretty handy to have the derivative of the square root of x memorized. Now, I'm fairly happy with this right here. I'd really like my answer to be, and I'd really like to be able to put these x's together. The square root of x is the same thing as x to the positive 1 half. And when I have a variable times a variable, what do I do with the exponents? Add them together. So what's 1 half plus 1?
1 minus 1 half. 3 halves.
So let's make that 3 halves. And let's make this over here 3x squared plus 8 over 2 squared of x. Alright, I have 2x times cosine of x minus 2 sine of x. So 2x cosine of x minus 2 sine of x. What are your thoughts on this one?
Cosine of x and cosine of x minus 2 sine of x is the one thing.
You have to take the derivatives of both of them and then subtract them.
Right, and that's what I want you to see. What do I have to do to get the derivative of that? What do
Product.
I got to use the product rule. Do I need the product rule there? No. So I need the product rule in the first part, and then I just need the derivative of the second part, and I subtract them, like Zach said. Zach, remind me again, what's the product rule?
First times derivative of the second plus second times derivative of the first.
All right. So first would be 2x. Derivative of the second would be negative sine of x. Plus the second would be cosine x times the derivative of the first, which would be 2. And then I need minus the derivative of 2 sine of x, which is 2 cosine of x. Now something I do want is I do want my sine and my coefficients to be in front. So if I do that, it's negative 2x sine of x plus 2 cosine of x minus 2 cosine of x. So I really end up with just what?
Negative 2x sine.
Negative 2x sine of x. That's all there is to it. All right, quotient rule. I have to use the quotient rule, obviously, when I have two functions that are being divided. Again, I'll show it to you, and then I'll tell you how you need to remember it. There's the quotient rule.
It's pretty much the same thing on top except you're subtracting.
Pretty close.
Yeah, but the bottom is
But now it's a specific
the
word.
top.
All right, here's how you memorize it. Bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared.
Oh, the bottom square.
That's how you remember it.
Bottoms up.
Bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. Bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. That's how it needs to be memorized. Right there. So let's apply it. Okay, let's say I have this function right here. X squared minus 4 divided by 5x plus 2. I know I have to use the quotient rule because I have one function divided by another function. Alright, who can recited to me already. Jasmine?
Top.
Jasmine?
Bottom times derivative of the top minus top times derivative of the bottom over derivative, no, the bottom squared.
Very good. So I've got the bottom, which is 5x plus 2, times the derivative of the top, which is 2x, minus the top, times the derivative of the bottom, which is 5, over the bottom squared. Yeah, I'm happy with that. The next one, I have f of x equals cosine of x over 3x cubed. F of x equals cosine of x over 3x cubed. Chris, what's the quotient rule?
Bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared.
Very good. Alright, so I've got the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. Okay, now this one I want to go ahead and simplify because there's something I want to show you
Gosh darn it.
that should happen whenever you're doing the quotient rule. So on the top, I'm going to get negative 3x cubed sine of x. I'm going to get minus 9x squared cosine of x. And what do I end up with in my denominator?
9x to the 6.
9x to the 6th. And do you notice anything that I can do?
Take out of 3x.
Take out a 3x squared. So if I take out a 3x squared, that leaves me with negative x sine of x minus 3 cosine of x. And on the bottom, it would be 3x to the 4th. Now the reason why I did that is because I wanted you to look at the denominator of what I started with and the denominator of what I ended with. Mainly the exponent. What do you notice about the denominator of what I started with versus what I ended up with? It increased by 1. Whenever you take the derivative of a quotient, your denominator should always increase by 1. Okay, so you can always simplify it to where it just increased by 1. So when I got to this point right here, I knew that I could reduce something because I should end up with x to the 4th on the bottom. So when I did it, I knew that something could be reduced. Now sometimes, if I did this problem and I ended up with x to the 4th already, what does that tell me?
You're done.
I don't need to reduce because I've got the correct exponent in my denominator. Makes sense? On 18, it asked me to find the derivative and then find f prime of c. So f of x is sine of x over x, c is pi over 6. So let's find the derivative. April, what's the quotient rule?
Bottom times derivative of the top minus top times the derivative of the bottom over the bottom squared.
Very good. Alright, so bottom would be x, derivative of the top would be cosine, minus the top times the derivative of the bottom over the bottom squared. So what does my bottom tell me already? I don't need to simplify anything.
I know one.
Do you want us to simplify though? When we are in the case where we can?
Yes. It wouldn't hurt.
Okay.
That way you can double check yourself. Alright, I want f prime of pi over 6, so I plug pi over 6 in everywhere. Now we're going to go ahead and reduce that, but if this is the AP test and it's the free response part, and they're wanting you to find f prime of pi over 6, all you have to do is plug in and you're done. Okay, however, we're going to go ahead and work this out because we're not very good at evaluating trig, so we need as much practice as possible. All right, so I've got pi over 6. What's cosine of pi over 6? Radical 3 over 2. What's sine of pi over 6? 1 over 2. If I square that in the bottom, I get pi squared over 36. All right, I've got the fraction within the fractions. What do we do to resolve that? So multiply by what? 36. Multiply by 36. So this is actually 2 times 6, which is 12. So that leaves me with 3. So this would be 3 pi radical 3. 36 and this, that's going to leave me with minus 18. And then those are going to cancel, and I'm left with pi squared. So that means f prime of pi over 6 equals 3 pi radical 3 minus 18 over pi squared. All right, Garrett, product rule.
Product.
Product rule.
First times derivative second plus second times derivative first.
Very good. Amelia, quotient rule.
Bottom times the derivative of the top minus top times the derivative of the bottom over bottom squared.
Very good.